Good morning all. This is Shiva Shankari from St. Joseph College of Engineering, working under the Department of Artificial Intelligence and Data Science. Today the lecture topic is on solving a LeetCode problem 42. It is a trapping rainwater problem. How to solve this problem? It is a hard one. How to solve this problem? What is the given question is, given n non-negative integer representing an elevation map where the width of each bar is 1, and compute how much water it can be trapped after raining. Okay, so they have given the heights of the building, so that we just need to calculate the how much water may be trapped if the given elevation map, through this given elevation map, how much water will be going to be trapped here. So we just going to be see it here. Okay, first we just take a question of how units of water they have given here. So what are all the units they have given means they have given 0, 0, 1, 0, 2 and 1, 0, then 1 and 3, 2, 1, 2 and 1. So these are all the elevation map they have given. So how to draw this means, first we just need to draw a unit. So they have given an 0. First you have 0, so nothing is there, the building height is nothing. So first next one is 1, so we have 1 unit. So here 0 and here 1. Next is also 0, and next we have 2 units of building height. Okay, so this is 2. Okay, so next one is we have 1 unit of building size, so 1. So next we have 0 unit of building size, and we have 1 unit. Next one we have 3 units of building size. So it has 3 units of building size. So next we have 2 units of building size, so 2. So next we have 1 unit of building size, 1, and next we have 2 units of building size, it is 2, and next we have 1 unit of building size. So if suppose water is going to be trapped in a position means how it will be trapping? It will be trapping if both the sides are closer, then only we can store some item in that closed like container, right? So if 2 sides forms a building, then if in a center position we don't have anything means in that position we can able to trap water, right? So we have to look into it. So trapping a water might be here. We select next color. So here 0 is in the first position. We have to look both the sides, both left and the right side. So in the first position we have in the left side nothing is there, in the right side we have a building is there, 1 unit of building is there. If water is there means also it will be splitted. So water we can't trap the water here. So here nothing trapped and water will not be trapped here. In the second position we have a building of 1, and we look into it, first position it will be trapped, and second position also we don't have any water. In third position, looking into a third position, left side has a 1 unit of building and right side have a 2 unit of building. So we will be stored water in this position, right? So how much unit of water has been stored? If we look carefully in both the sides from left and right, we can see equal. If it is an equal size, the equal unit of water will be stored. If it is not an equal size, if left and right, the minimum height of the building will be store the water, because the water in this position also split down and it won't be trapped here. So minimum position of the building height will be taken to trap water here. This is the concept. So how much water will be trapped here? Here 1 unit of water will be trapped here. So here 1 unit of water will be trapped. So looking into our next three positions, so here coming to a center point, how much unit of water will be stored here? So here from the left to right, we have to look the minimum and maximum height of the left and right position of this center position. So looking into the left side of this center position, the maximum height of this is the 2 units. So here looking into right side, the maximum height is 3 units. So here 2 units and here 3 units. 2 units of water will be stored here. So here 2 units of water has been stored. So here from this one position, here 1 unit, here 1 unit will be stored. Totally how many units means 2, 3, 4 and 5 units will be water stored. Here 1 unit, here 2 unit and here 1 unit. So total here we have 1 unit of water. So 2, 3, 4 and 5 units of water will be stored here. Looking into this position, it will be covered both the sides of water, both the sides of building height is there. So here the height here will be stored 1 unit of water here. So totally to this elevation map, we might be store the 6 units of water here. So how we calculating the water means, we might be, if suppose water height will be calculated like this. So water height we might be calculate taking the minimum position of the left max and right max will be subtracted with the height of a current position they are there, what they having. Okay, so considering here, so here, so see if it is an if suppose we just considering this position here, 1 unit of water is storing, right? How we calculated is, so we just going to be take minimum of left max. So left maximum position we have is 1 comma, right maximum position what we having is 3. So 3 here. So finding out in this minimum position is 1 minus of what is the current height here. Current height of this position is 0. So 0 equal to how much water we can store here. 1 unit of water is stored. So like this we just going to be calculated. So considering this position, so we have to look into it. So from the center of the position, how we calculate is, we just going to be take the minimum of the current position, left maximum. So here left, which is maximum value here, 2 is a maximum value here. Looking into this position, with the help of this right, which right is maximum here, right in this right side, 3 is the maximum position here. So we have to take the minimum of 2 comma 3. So minimum of 2 comma 3 is 2 minus of the current height is what? 0. current height is 0. So we can from this center position we can store a water of 2 unit. Like this we have to calculate. So looking at this problem, we have to think about it. So for each position, if we calculated the left max and right max, for each position it is going to be calculate everything, means it might be taking of time complexity of order of n square. So we just need to think about how to reduce it. So this is a naive approach to solve this problem. So if we think another way how to solve this problem, means we can maintain the left max and right max as a position. 1 minute. So if 1 minute. So we just need to calculate the left and right max position. So how we take it is, so left and right max position. So looking into the problem, let me draw the graph again. Units they have given is first 0, first one is 0, next one is 0, next 2 units, next 1, next 0, next 1, next 3 units, next 3 units, next 2 units of building height, next 1, next 2 unit, next 1 unit. Okay, so for this we just going to be calculate the left max array and right max. So once we calculate this left and right max, we no need to calculate again and again in each position. So looking into our first position, what is the left maximum here? We just going to be see only on left side. So first position nothing is there, so left maximum is 0. Left maximum is 0. In second position also left maximum is 0. Looking into third position, the left maximum is 1. So looking into fourth, the left maximum is 1, and looking into the fifth position, the left maximum is 2. Next also left maximum 2. Next is also left maximum is 2. Next is also a left maximum is 2. Next is the left maximum becomes 3, and the left maximum becomes 3, and the left maximum becomes 3 here. Okay, so here 3, from this it is 3 and 3. So next we just going to be calculate the from last position. So from right maximum we just going to be see. Since first position doesn't have from the last, if we looking into it, we don't have any right side is there. So initially it is 0. Next if we look into from this position, it is 1. Maximum height is 1 from here. Here maximum height is 2, and here from here the maximum height is also 2 here. From this position also the maximum height is 2 here. From this position the maximum height is 3. From this position the maximum height is 3. Again everything becomes 3 here. So every position becomes 3, 3 and 3. So once we find out it, we might be calculate the water's current position, and we might be calculate the with help of minimum of left max and comma right max, which is going to be subtract the height of a current position. Okay, so like this we just we can solve a problem. So we just look into this code and we start solving the problem. Okay, so here how to solve this problem means how we have maintained solve the problem. Okay, so first we just need to, here they have given an public int of trap, a function of height. Okay, so first we just going to be given initialize an n value equal to, we just going to be fix the height length, okay. So first the base case should be there if they have given a non-negative integer. Okay, so non-negative integer in the sense the given array is going to be as a positive integer. So if anything is goes as a negative integer, we can't solve the problem, right? So base case should be right here. If the n value is equal to 0, we might be going to be return it as a 0, because nothing is there means we can't calculate the units of trapping water, right? So if suppose any height given height, if we have a given height length only, we can calculate the trapping of rainwater, right? So next we just going to be what we have seen, we just maintain two different arrays, right? So two different arrays we just need to initialize with an array of, we just going to be maintain left max and left max equal to, we have to give the space, right, int n for the given n height length, we just going to be fix the left maximum array. Same as that, we just going to be calculate the right maximum. So right max equal to, we just assign the memory space to an n length, we just going to be form an array, right? So what is next means, we just need to calculate the left max here. So we just where we just started here, the left maximum index 0 is going to be start from the height of 0, and the right maximum will be calculated from the last position. So how we can mention the last position is n minus 1. N minus 1 equal to height of, we just going to be calculate n minus of 1 here. So Next we take a for loop to traverse the left array and left maximum array and right maximum array. So left maximum array will be start in the position of I equal to 1 and I is how much I equal to first from the first position which is starting less than of n to the position it is going to be traverse and the I value will be incrementing through this from first position to nth position. It is going to be the loop is going to be traversed, right? So here we just going to be calculate the left max of I is going to be calculate the map dot maximum of left maximum of left max of I minus 1 from I minus 1 comma height of I. It is going to be compare the left side only. So I minus 1 position comma the current position to compare these two position and it is going to be calculate the which one is maximum. So in the left array always concentrate on left side position and it takes the maximum value of height is going to be calculated here. Same as that we just going to be take a for loop of int I equal to here I value is going to be take the last position here. So last position in the sense n minus 2 comma from where it is going to be from it is going to be end in the starting position. So I is going to be greater than or equal to 0. It is going to be terminate. So loop is going to be terminate where I is minus minus. So we just going to be decrement it, right? So next we just going to be find the right max. Right maximum is going to be calculated equal to same as the math dot maximum of we just going to be calculate the right maximum of I here we just going to be take right maximum of I current position and comma we just going to be calculate increment the value, right? So how so it just moves to a forward and compare the height with I. So after calculating the left and right max we just going to be calculate the total number of water units. How much? The 6 we just going to be calculate that. So we just from this array we just calculated the left maximum and right maximum. We just store it in the separate array. Here we just going to be calculate the units, how much units it's going to be store the trapped water here. Okay, so here we just initialize the total water how much it is going to be stored. So we just going to be initialize one variable as total water equal to 0. Okay, so here for this also we just creating a for loop. So it is going to be iterate int I equal to 0 from 0th position to I is less than of n and I increment. From this increment we just going to be calculate the total water is going to be calculated here. So how the total water is going to be calculate here? With the help of the left max and right max array, we just going to be taken value here. So how we just going to be add the value of map dot minimum value is going to be compared. So from the left maximum array and right maximum, from the left maximum array and the right maximum array, we just going to be compare these two arrays, and we just going to be take the minimum value, and then we just going to be subtract the current height to get the how much unit of water is going to be stored. So here from the left maximum array we might be getting, if it is in this current position, we just going to be look the left maximum position of this position and right maximum height of the from that position. So compare these two and we take the minimum height and we subtract with the current height, so that we can able to know how much water is going to be stored here. So same formula we just going to be use here. The total water is going to be subtracted with the values. So traversing all through this array, we might be adding the how much water is going to be trapped. So here 1, 2, 3, 4, 5, 6. So through this formula it will be calculating the values, how much unit, and then in the last we just going to be return the total water they have stored here. So how to write this means, so we have to think the left max, take the left max and right max, and with the position left max and the right max, we just going to be subtract the height of the current position. So height of the current position is going to be subtracted here. So next we just going to be return the left we just going to be return the total water here. Total water units, how much units we are being accumulated is going to be calculated from here. So if we run this code, we might be seeing here. So here error is being showing here. So for loop total max of here we might be having an semicolon and here semicolon and run the problem. Okay, so how much total units it has been calculated. So here for this given array it's been calculated, the 6 units has been calculated, has been shown here. So thinking of this problem, have to submit this problem also. It takes time and we have submitted the problem. It has been run. The problem has been completed. So the time complexity of this problem is order of 3n. So you have used 3 different loops. So running a problem might be taking 3n. So commonly we can say it as a order of n times. So what is the space complexity of this problem? Space complexity of the problem is also an order of n times, because we might be using the array space here. So the space complexity is also an order of n times. So comparing to this problem, we can solve in many different ways. Even we can optimize the problem into not an order of n times. Even we can try to solve this problem in a minimum number of time. So giving a problem solution is, we have different solution for the given problem here. Thank you.